Welcome everyone uh, to yet again another edition of Twitchline CS. Today we're going to finish up on what we started last week, so it should be a fairly light. Hello, Zeiss. Should be a fairly light session today. We're essentially going to strengthen again our fundamentals of routing. We're going to work a little bit over IP routing again, and I kind of want to do a live demonstration of Wireshark also today. I think that would be kind of interesting. Um, on top of that, so we're still waiting for our second student scout. Daniel is with us already. So what we're gonna do in the meantime is we are going to. So Daniel has an assignment for his classes, and one of the part of the assignment is to determine something that we haven't talked about in this lesson yet. The reason I don't talk about it is because it's fucking useless. Like there's no other way to put it. Like the only reason you'd bother with that is to have some historical context for why some things, some default values are what they are. But it's fairly useless. However, since the subject is brought up and we have a little bit of time, might as well just get it, you know, get it done. So, hello, Daniel.
Hello.
Can you see my screen?
Yes, I can see your screen.
Okay, great. So, Daniel, can you tell us? So, you were telling me about your assignment. Can you give a brief description to chat of what the assignment is?
Okay. So I have to do. I have a list of URLs, and I have to determine their IP addresses, uh, their class, of its networks class, and also I have to ping them and to see how many packages are received, lost, sent, and how much time do they take to arrive.
Right. So fundamentally, uh, one of the first thing is determining the IP from the URL. That is actually going to be we're going to go a bit more in depth uh, on that. Had planned that for next week, but we could do a little bit of that today. That's going to be using a protocol called DNS. So have you heard of that before, Daniel?
Yeah, we kind of see what it was, but we didn't enter into technical details.
Right. So basically, the idea is just you have a name that's like DNS means not quite. um, Basically, the idea is you have a like an understandable name, like Google.com, and you would assign it an IP address like I don't know, like 1 2 3 4. The reason we work this way is because for a human being it's much easier to remember google.com rather than 1.2.3.4. That's actually the only reason. I mean, that's one of the main reasons why we do this. Another really cool thing about DNS, and we will have the opportunity to set that up, is that in if you can use DNS in like an enterprise environment, like internally. So you could for instance have different. Let's say you have different servers, right, internally inside your enterprise. You have internal servers, right, for your intranet. So let's say like you have a finances server and you have like an IT server and you have like a marketing server, right? So you have several servers um, that are like connected to the network. These servers, so what you can do is you can make it so that the end users and like the end users, there's like an entire infrastructure, but like we're just gonna gloss over that and assume they're just directly connected. The the end users, you can make them connect to it through an IP address. So like you can configure the end users workstations. You can pre-configure them with IP addresses, and that would work. One issue will be that let's say you want to move the finances server, right? You want to move it somewhere else, right, in the network. Well, there is a chance that its IP address will be different, right? It will have a new IP address. The problem is suddenly you're going to have to reconfigure every single one of the workstations. That's a lot of work. Instead, what you can do is use a DNS server where you essentially you're going to in your infrastructure there's going to be a dedicated server that's going to handle those requests. But the fundamental idea is you're going to say finance server equals IP address number 1, right? And then the day you do the move, you remove that entry and you say finance server means IP address number 2. So suddenly the IP has changed, but the name hasn't. So that can allow you for some flexibility. That's actually something I use very frequently myself, because in my home lab I have a lot of virtual machines, and I can't remember. First of all, I can't remember all the IPs, but also their IPs change quite frequently. But I want to know what I'm accessing without having to look, oh, like what's the current IP address. Whereas if I just give it a name and like I have software that automatically makes sure that I can access it via a name even if the IP changes, then it's just much easier for me. Not only is the name easier to remember, but if the IP changes, the name doesn't. So that's that I'd say that's like the two motivations for DNS. So the first thing you want to do is do it like is figure out like, okay, I have this URL, I have this domain name, because it's not actually a URL, it's actually a domain name. It because those aren't quite the same thing. A URL is like a domain name plus a page, whereas a domain name is just, it's basically an IP address. Okay, let's put it that way. A URL is an IP address plus a request. A domain name is just an IP address. So what we can do is use the Windows command line. Okay, clean. Nope. Okay, whatever. Is use the Windows command line and do a command called nslookup. So nslookup, for instance, for google.com. NS stands for it's the same NS as DNS. That's how you remember. So nslookup is basically to do a manual DNS request, and you're asking, hey, what's the IP address of, for instance, this domain name google.com. And here, non-authoritative answer, that's where you find your answer. And you see two addresses. You see a long address and a short address. The long address is the IPv6. There might be several of them. The short address is the IPv4. There should only be one. So, Daniel, the first thing you can do is for each of those URLs, you just do nslookup followed by the URL itself, and you will find the IP addresses. And my suspicion is that you're being asked to look for the IPv4s, but I'm sure they wouldn't duck points if you also included the IPv6.
Okay. Yeah.
Right. So is that really clear, that DNS thing, name system?
Yeah, it's way clearer. Yeah.
Okay. So you can just do that a few times and you'll find the IP addresses. Now, you said there was something else also. You said that you are being asked to, where is my pen? Where the hell? That's kind of funny. Give me a sec. Oh, okay, I found it. Okay, so it's right here. Um, so the class. Now, a little bit of history. When the people who designed the IPv4, when they designed it, very quickly they realized that we were going to run out of IP addresses. Like basically 6 months after like releasing the specifications, they realized, oh fuck, this is not enough. This is too small. So they tried several measures to basically save as many IP addresses as possible, right? To make it more scalable, to make it so that even though you like basically there is just too few bits. Like if you just count the amount of IP addresses, you just realize there's not enough of them. That like the what we call the addressing space is just too small. One of the first measures that was tried to counteract that was to segment was the segmentation of the IP addressing space. The fundamental idea was this: we have the entirety of the IP addressing space. So let's say this is the set of all IP addresses, all of them. And what they said is, okay, let's say these ones are gonna be for like small networks. These ones are gonna be for medium networks, and like these ones are going to be for big networks. And then there is a bunch others that we're not really going to mention. But this segmentation was the first idea, was the motivation behind the concept of classes of IP addresses. Idea being, the initial idea was just to like waste as few addresses as possible. Like if you only need few addresses for your network, use an IP for small networks. Um, Now, how exactly do we define small networks, medium networks, and big networks? Daniel, do you have an idea? Like, if I was to ask you from an IP perspective, how can you tell if a network address, and I do mean network address, how can you tell if a network address is for a small network or a big network? What do you look at?
I think that I would look to with I would look their prefix.
Right. So let's take for example. Um, I'm gonna give you two examples, and I want you to tell me which is the bigger, quote unquote, the bigger network. So, for instance, we have 192, 168, 10/24, and on the other hand, we have 10/0/8. Which of the two is the bigger network?
I think they would be the second one because it has a lot of IP addresses that could be used.
Exactly. So your answer is perfectly correct. Just for the stream, can you run us through your thought process a little bit?
Okay, so for example, the first one looks kind of what I have at my home.
Mm-hmm.
Uh, right now I only have my, some computers and maybe my phones.
Mm-hmm.
So I only need 1, 2, 3, 4, 5, 6, 7. I don't know. But um but the second one, because it has only one number of prefix, I think that maybe you could have a server in with the point one that connects to other machines that could use, for example, 10.1.1.1, and then blah 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 the 2 to 3. And when you feel 10.1, you could then feel 10.2, and so on until you run out of numbers.
So your assessment is correct. It's not very well defined.
Accurate?
So I'm gonna, yeah, it's a little bit inaccurate. The idea is correct. But to be very precise, what we actually look at, we don't even care about this part. Like, we genuinely don't give a shit. What we care about is the mask. The mask is what we look at. Now,
Okay.
Daniel, what conclusion, like if I know the mask for a subnet, what conclusion can I draw about that subnet?
The prefix, right?
What's that?
Uh, that if I look at a mask,
Mm-hmm.
I can see how many bits are used for the prefix.
Yes. And therefore, like if
The,
I know how many bits are used for the prefix, what about
I
the
also
the other
know
bits?
I also know which ones are free to use.
Exactly, for the devices. So give
Oh,
me 1 second. Scout, don't worry. What we're doing right now is a little bit sidetracked. You haven't missed anything. It's just Daniel has an assignment, and we're just covering that right now. This specific topic is not something I wanted to cover in the class anyways because it's completely useless. But I'm just trying to help Daniel out right now. That's about it. So
that,
you haven't really missed anything. Okay. So basically, the bigger this number, the bigger the mask, the fewer devices I can have in the network. Do you agree with that?
yes, I do agree.
Okay. What's the formula? Because like this isn't like an approximation. Like if I give you a /24 network, how many devices can you have running? How many different IP addresses can you use? How many IP devices can you have?
255.
Almost. It's actually 254.
Yeah, yeah, the top and the bottom. Yeah, I
Right.
remember.
Can you remind us of the formula? Do you remember the formula?
No, but also it would be um, so we have the bits that that we can't use. So we can't use 3 bits due to the mask
3 bytes. Careful.
bytes.
Right.
Yeah,
So
just
that leaves
basically.
us with 1 byte, so 8 bits, right?
Like,
So we can use eight. My God. We can use 8 bits to address the devices.
yeah,
Eight. How many numbers can you store in 8 bits?
2 to
Two
the
to the
power
eight.
of 8
Right. And
minus 2.
that's 256. And you are correct that that's 256 addresses total. 2 of which are reserved. So we do -2, which is 254. 54. Okay. So when you were taught, I thought it was kind of funny where you were mentioning your home network and you have a 192.168, and you're like, oh, it's like I have my phone, my PC, but like it's a small network. It's like you can have 254 devices in your home network, which sounds big, but maybe isn't. But it's actually way more than you'll ever use, most likely.
Yeah, yeah.
But it's still considered small. And so the real part that's interesting is a /8 256 game consoles. You would not be able to plug 256 game consoles. You would only be at best able to plug 254 of them together in the same subnet. Otherwise, you'd have to route between different subnets, or you'd need a smaller mask. You'll donate the rest, then why buy? Okay. So let's do the same formula with a /8. So how many bits do we have to address devices? Well, it's the mask is 32 bits minus 8, it's 24. So then we do 2 to the 24, which is big. I think it's like okay, I think it's
I can make the calculations
no,
here.
I think it's 16 million. I think it's 16 million. Tell me
Um,
if I'm right.
16 million. Yeah,
Got it.
17 million.
Yeah, it's 16 million, roughly.
Yeah.
It's roughly 16 million. So yeah, 16 million minus 2. It's 16 million compared to 254.
Okay, yeah,
Okay.
fair enough.
So the idea was, okay, by default, let's give some IPs a /24, others a /16, and others a /8. And then there are some outliers.
Okay.
The IP addresses with the small mask, so the /24, are class C, the medium ones are class B, and the big one are class A. So the idea is there are specific IP addresses that by default will have either a /24 or a /16 or a /8 mask. Now, I'm going to ask you to try and remember when we were on Packet Tracer. When we were configuring IP addresses, do you remember, like, do you remember the mask auto completing itself? Like, what you would enter an IP address and the mask would sort of auto complete itself?
Mm-hmm.
Right. That's because the address we've been using, the 192 blah blah blah, that address is a class C. So by default, the PC is gonna assume, okay, by default it's a /24.
Okay.
But again, it's an assumption. We can still modify it afterwards, but it's just, by default it's a /24. Class A would be, for instance, 10.0.0.0. That's a class A IP address. That's why when I've been using 10.0.0.0, I've given it a /8 because it's a class A. And if you were to go on Packet Tracer right now and configure a PC with a 10.0.0.1 IP address, by default, the mask would be 255.0.0.0. Class B is a little bit, I haven't used class Bs because they're kind of like annoying. It would be like 172.16 up to 172.31. It's wait, no, that's for private IP addresses. Never mind. But like that would be the equivalent. Like if I was to use something equivalent to 192.168 for class C or 10 for class A, it would be a 172.16 for a class B. And that's just a lot less elegant, and it's not used very often. It's usable, but it's not used very often. It's still hard to write. So like for educational purposes, I like to use the 10.0.0.0 because it's easy to write. To make it more relatable, I like using 192.168. This one is kind of an outlier where like no one's ever seen that, and it's not very practical to use. And there are other reasons that make it very impractical. But those are just examples of class A, B, and C's. These addresses are not the entirety of classes A, B, and C. So the question becomes, so those are just examples. So the question becomes, how exactly do we determine which IP address, like how do we determine the class of an IP address? And the secret lies in binary conversion. So let's take, for example, 10.0.0.0. And let's write it in binary. So that would be 0, 0, 0, 0, 1, 0, 1, 0, and then everything else at 0. Easy enough.
Mm-hmm.
We know it's a class A because the first bit is a 0. So we look at the first bit. If the first bit is a 0, then it's a class A.
Okay.
Now let's look at a class B. So that would be, again, something we're not really used to. But for instance, 172, 16. Actually, you know what? Just 172. That's enough. 0, 0, 0. Again, binary. So that would be 1, 0. Let me make sure. Hold on.
Yep.
What's 190? What's 172 minus 128? That's 52 minus 8. That's
44.
44? Okay.
Yep.
So let's see. 128, 64, 32. You said 44, so that's 12 left. 16, 8, and it's 4. Okay, there we go. We got it. Doing live math. Hell yeah. Quick maths. So this would be 172 in binary. And we know the first bit is a 1, but the second bit is a 0. So it's a class B. And then if we look at the infamous 192, 168, I'm not going to bother with 168 because I think you get the gist of it by now. That's 0, that's 0. Again, decompose it in binary. That's, I know it's 110, and then I think that's it actually. 64 plus 128. Yep, that's it. 11000000 dot, and then it's gonna be 168 00. Okay, and we notice first bit is a 1, second bit is a 1, but third bit is a 0. So that's a class C. So basically, we try and look at the first bit that's a 0. If we go from the very beginning of the IP address in binary, and we look for the first occurrence of a 0. If the very first bit is a 0, then it's a class A. If the second bit is a 0, is the first 0, then it's a class B. And if the third bit is the first 0, then it's a class C. Now, there are classes D and E, but we don't care about those for all intents and purposes. So for your assignment, what you'll have to do is first do the NS lookup to find the IP addresses, then decompose them in binary to find their classes. And from there, it's pretty smooth sailing. All you'll have to do is just, ping. And, when you do a ping, so let's say I do a ping to 216.58, 213.78. So that's the Google server. I just ping it. There we go. I have some statistics. So 4 sent, 4 received, 0 lost. The minimum is 2 milliseconds, maximum 14 milliseconds, and average 8 milliseconds. There we go. That's pretty much all you have to do.
Yep.
All right. Is this all clear?
Yeah, pretty clear.
Okay. So also, the reason I say that it's fucking useless to know the classes is because in practice, that was completely pointless. Because better segmentation of the IP addressing space does not save, it doesn't solve the problem. What ended up solving the problem is a technology called NAT that we will go over later, probably in a couple of weeks, if not a little bit more. It's kind of an advanced topic. Somewhat advanced.
This might be a good time.
Yeah, I noticed you weren't here. Hi, Scout.
Hey, sorry, since I'd gotten home, I just had to change my clothes real quick since I saw you were doing something different.
Yeah, no worries. If you're interested in this, you can absolutely watch the VOD. It's not particularly I don't find this particularly interesting nor important, but you're free to.
Yeah, I'm so sorry for being late. Work kept me late, and then I got stuck in traffic.
No worries,
There's road work going on my way home. So.
No worries.
Okay. I'm ready when you are.
Daniel, how do you feel right now? Do you want to maybe take a 5 minutes break?
Yeah, that's fine with me.
Yeah, it will be it will be helpful to make me assimilate and avoid interference.
Sure. Yeah, like this took a little bit longer than expected. Sure, let's go ahead. Let's take a 5, and I'll see you guys in a little bit.
Okay.
So chat, it's you and me once again. Um, let me know if you have any questions, though I somewhat doubt it, but feel free to ask. Weird champ, exactly. So yeah, I had planned originally to sort of stream earlier tonight and stream like I was interested in doing a short series where I would program um Twitch bots using different languages. So I was thinking, okay, like let's do one in Python, and then let's do the same one in Java. Let's try doing the same one in C++. To just try and see. First of all, Twitch bots is actually a very cool thing to make, because let's just say that MooBot and Nightbot, they are extremely useful, but they're also limited in what they can do because, well, you're limited to the API. And also, they have to they have to generate revenue, which means you're going to be locked out of functionalities kind of for the sake of it without no technical reason. So if you can just run your own bot, you don't have those limitations anymore. And also it means you can do much more in-depth stuff in terms of integration. You can, and that was my plan for a little bit, though I didn't follow through on that, but let me know if you'd be interested. Essentially making the same bot. Essentially, I'd be interested in making a bot that is a Discord bot and a Twitch bot, has integration between the two. So it's not just the same set of commands. It's like you'd be on Twitch and you'd interact with the people on Discord, and also have an administrator web interface, kind of like what Nightbot or MooBot offers, but except it's just on your PC. So I think that would be kind of cool to do. It wouldn't be particularly difficult either. It's just like at that point, it's just more like I'd be struggling to find ideas of commands to put in the bot. It's like, okay, I'm saying, oh, integration between Twitch and Discord. It's like, how does that work in practice? Like, do the people on Twitch rate the people on Discord? Is that how it works? Because that'd be funny. Could also be something like when you here's an idea. So I'm writing that down. I could make a clips channel on my Discord, and then basically have it so that when you guys clip something, for the sake of demonstration, right? I'm not saying that you necessarily clip a lot, but like if you guys clip something, you can use the exclamation point clip command in Twitch, followed by the link of the clip, and then the bot would automatically send that clip over to the clips channel. That'd be kind of cool. Dang plays in Smash. I don't think we'll be playing a lot of Smash on this channel. But yeah, that'd be kind of funny. Yeah. So let me know if you have ideas for like bot integrations between and the thing is, making making a Discord bot is a little bit more difficult, but a Twitch bot is especially easy. Like making a Twitch bot is really, really, really easy because Twitch provides, first, you have two ways of going about it. Twitch is basically just an IRC channel. So like either you use like an IRC library, which is really simple to use. I mean, it's basically just read message and send message, and that's really about it. So at that point, it's like very low level, but then you have plenty of freedom. Like the library is super simple to use. Or you're using the Twitch API, which is still fairly simple and gives you a lot more flexibility. Like for instance, you can monitor people's points. You can monitor the channel's clips. You can monitor the viewer count. You can monitor a lot of things. And then the chat, obviously. And it's fairly simple to use, whereas the Discord API, from experience, it's a little tricky, a little trickier. Like, yeah, it's a little trickier. But I think people would definitely gain from being able to like make their own bots, especially since a lot of people like. Hold on, I need some water. So, most people use like Twitch bots and whatnot, mostly just to like have just commands like exclamation point schedule and just have the schedule in a Twitch in a chat message, and that's it. And it's true that if you want to do anything more than that, it gets a little bit more difficult, technically speaking. So it's not necessarily accessible to everyone, and it's not necessary like, and that sort of command of just like ban Twitch. Like that could be a fun one, right? Like a witch hunt sort of command. Okay, that Twitch, that's a joke. But like where people in chat would vote to like time one person out, and then the bot being a mod could actually do it. Like that would be funny, right? And I don't think that's something you can do with channel points. So yeah, that'd be kind of funny. Time people out for making puns. Well, the bot would have to detect the puns. But this is where it gets so cool as well, right? Like if you are a developer and you are really good at what you do, like let's say you're an AI researcher, right? And you're researching natural language. So basically you're making a bot that can actually understand chat. You could make it like automatically react to stuff. Like not necessarily talking about TOS, but like you could make a bot that literally reacts to bad puns and times it out. Like you literally could. That's kind of funny. Funny to think about. Or alternatively, you could have like a bot that like anyway, like you could do a lot of interesting stuff. I'd be down to try and I've done a couple projects with AI before, with like free AI APIs. So I'd be down to try some stuff. Yeah. Sure, we can try that. So let me know in the comments below if you would like to see anything specific, right? I'd be very interested to do that. All right, we're gonna hop back over to Discord, see if Scout and Daniel are with us.
I'm here.
Hi, Scout. Is Daniel back?
I don't know.
Yeah.
Yes. Fantastic. Okay. So, last time. What did we do last time?
We were talking about routing and basically like packet tracing and things like that.
Packet tracing. Did
Or
I?
not packet tracing, like like I was talking like Wireshark and things like that.
Okay, yeah.
Right.
So, did you install Wireshark?
Yes. Although I actually don't have it on my current computer because I just
Right.
swapped over to my desktop.
I suggest you install it real quick. It's not very heavy.
Yeah,
I am going to make a demonstration of Wireshark tonight.
Let me also go back up. I just realized just now that I don't have Wireshark, and I'm gonna download the packet tracer again. 1 second.
Oh yeah. I don't think
Sorry,
the link. Yeah, the link is not gonna work anymore.
Oh, that's fine.
If you
I can.
no, hold on. Give me a second. I'll fix that. I'll fix the link.
Sorry, like literally that just dawned on me now because I've used the same monitors and the same setup, just different computers. So I didn't.
Yeah. I know.
And yes, I know the whole like just move your hard drive over. The issue is it's I didn't want to have two OSs on the same system, and it's a
You
different
didn't
kind of
have to.
SSD. No, I didn't. That's
Okay.
okay.
And
Wireshark's installing. I hope your day's been going okay.
oh, my day's been great. I'm a little tired, but should be fine.
For installation options, legacy loopback support, Nmap, restrict NCAP
I
driver's
mean,
license to.
doesn't really matter. You can leave it. You can leave the default options.
Okay.
And the link would be to download Packet Tracer. I'm
There we go.
hoping that that will work.
It's loading now.
Okay.
Wireshark's installing right now. Okay, I'm good.
Okay, so yeah, last time we went over IP routing. I'm hoping that the concept of routing is a little bit is clear now. You know, this idea that by default a router knows the streets of which it's, you know, it's a part of, and to have knowledge of streets further away, we need to fill up its routing table. And we can either do that manually, which would be static routing, or dynamically with, you know, dynamic routing protocols. But
Yeah.
again, I'm not going to go over those in this lesson. Okay. So this slide right here is basically more or less the essence of everything we've talked about last time, which is, you know, we have our router A, and it's by default it has knowledge. So here in this slide they only show a partial routing table for router A. Let's see. First of all, can you guys read the IP addresses correctly?
Yeah, I think I can.
Okay, I'm going to launch Epic Pen. Give me a sec. Okay.
I'm looking at them now. Okay.
Okay. So basically, you'll see that this here corresponds to, so 10.11.00/16. It's this network right here. Let's see, we have this one, the .12, which is this network right here, and 10.13, this network right here. So basically, what we've done here, what they've done, is they have manually told router A about the blue subnet, the purple subnet, and the yellow subnet. They've manually, like we've done last time, they've manually filled out the routing table of router A, without which router A would have no idea how to reach those networks.
Got it. Okay.
And what we see is the next hop here. So for instance, for subnet yellow, next hop would be 10.1.1.2, which is this IP address right here, the IP address of router B. So I know there's a lot of like numbers and names on screen, but if you take it one at a time, it's fairly simple. Or rather very predictable. To reach subnet yellow, you need to go through router B. Makes sense. Okay, here's the IP address of subnet yellow, and here's the IP address of router B. And the interface here is the outbound interface of router A, GE1000. Well, it's this one right here. So basically what we're saying is, if you're trying to reach subnet yellow, then you first have to reach the IP address of router B coming out of this interface right here. Does that make sense?
Yeah.
Okay.
Yep.
Okay.
And then you just run that basically like once for each server, once for each subnet. And you see like there's a lot of numbers on screen, but at the end of the day, it makes a lot of sense. To reach the purple subnet, we have to go through router C, so that would be 10.2.2.2. Oh, yeah, that's the same. Outgoing interface GE200, which is this one. And same deal for the blue subnet. So see how there's like a lot going on screen right now in this picture, but in reality, it's not that
a whole
much.
lot going on.
Yeah, it's more like each route is like a set of IP addresses and interfaces, and everything's on screen right now, so it kind of looks like a mess.
Okay.
But if you just follow one thread, it's very clear how it's defined.
Understood.
Okay. So what we're gonna do now, and now that I think about it, I should launch. We're gonna launch Packet Tracer, and we're actually going to configure our static routes. Now that we've, hold on, give me a sec. Okay, whatever. Now that we've seen how to configure IP addresses and how we're supposed to create to configure our routers, how do we do it in practice? Well, in practice, Cisco Packet Tracer is not actually going to make it very easy for us here, because we're going to have to use the Cisco CLI, the Cisco command line. In practice, if you have a home lab, or even if you're just using your home router and there is an option for static routes, which usually there is, you have a graphical interface. So you wouldn't have to type commands. It's more like, hey, do you want to add a route? Yes. Okay. Like what's the prefix of the route? So what's the prefix of the route? So the prefix would be like the destination. So what's the destination and what's the next hop? And that's about it. Right. The question is, CLI is just command line is just a little harder to read, but the fundamental is the same.
Okay.
I mentioned pfSense because that's like a very popular firewalling software, but for all intents and purposes, a firewall is a router. So, you can still add static routes to pfSense because it's fundamentally the same thing. So here are the 3 commands that you would have to use in a packet tracer, and we're going to do that together real quick. The first command to enter is enable, which basically allows you to enter privilege mode and actually make modifications to the router. Second would be show IP route, which is just to display the routing table to see that we basically haven't added static routes yet. And then we have a command to add the static route itself, and then we can check that the route we've added was in fact correctly added to the routing table. So let's go ahead and do that. And yeah, Cisco kind of makes me wait 15 seconds.
Yeah, sorry about that. Let's see.
By the way, have you guys familiarized yourself a little bit more with Packet Tracer?
A bit. I've opened it up a couple other times. It's just been at work a bit.
No, not really, but yeah, I kind of remember what I have to do.
Okay.
Also, my Wireshark install is a little stuck still, but luckily my packet tracer is still running fine. So.
Okay, so here's what we're gonna do. We're going to run 2 routers and 2 PCs.
Okay.
So let's start with the routers. We're gonna pick. Let's see if I can zoom in. No, I can't really zoom in on the list down at the bottom, so I'm not sure it's gonna be very clear for you guys. We're gonna pick router labeled 2901. I think is the one I. No, hold on, no. 21, yeah, 2901 should be fine. So we have two routers. And then we're going to add two PCs. And then we're going to wire everything up. And then right now I'm basically doing what we've done last time, which is like configuring the IP addresses and all of that. So I first have to decide on the subnets, the subnet prefixes. So let me do just that. So for instance, this one would be 192.168.10/24. And this PC would have the IP address 192.168.1.100. The router would be 192.168.1.1. Okay. On this side, this would be 10.0.0.0/8. So I'm not configuring anything here. I'm just preparing the configuration. Okay. This is subnet 192.168.20/24. Okay. So can you read my screen correctly?
Yes, I can read it.
Okay.
Same.
So now I'm gonna start configuring the IPs. So let's see. I go. So okay. By the way, so the last time we did this, I told you to configure the PCs. We have to go onto the desktop. There's another way of doing it, which might be a little easier, which is to go under config. And under the interface tab, there is fast Ethernet 0, and we can enter an IP address and a subnet mask right here. So that might be easier. That being said, it doesn't look like we have an option for a gateway, which actually we do need. So never mind, we actually will still go on the desktop, go under IP configuration, because we need to have the ability to enter a gateway. Otherwise, I mean, we know what happens when we don't have a gateway. So let's see, 192.168.1.100 with a subnet mask. Yep, default subnet mask. Okay. Second PC. Okay. See if that's correct. 100, 100, 100. Okay, looks good. Then I have to configure the routers. So let's go under config, turn on both interfaces. Gig 00, that is the one right here, which, well, this should be an option. Let's see. Okay, I can't figure this out. So this is gig 0. So gig 0 is going to be 192.168.1.1. Okay. Oh, I forgot to configure the in IP config. I forgot to configure the gateways for the PCs. So let's do that as well. Okay. Okay. This is 10.0.0.1. Default mask of 255.0.0.0. That's correct. So again, we're doing nothing. We're not doing anything new here. Let's see. Gig 0 is this one. Okay. Okay, so I should be done here, which means at this point from PC 0, I should be capable of pinging this interface. I should be able to, from PC 0, I should be able to ping 10.0.0.2 because by default, without entering any routes, my router 0 here on the left has knowledge of the IP address 10.0.0.2. So if PC 0 here was to ask the router, hey, can I reach this? The answer would be yes, I can. Oh, but then never mind, because then the way back wouldn't work because this router 1, has no idea how to reach PC 0. Not until we give it a static route.
Okay.
So,
Okay.
how are you guys doing on your configs? I suppose you're not quite ready yet. Maybe you need
I'm
a little
not
bit.
quite ready yet.
Mm-hmm.
Let's
I'm
see.
not quite ready yet.
Okay. I'm gonna give you a couple of minutes here.
Almost. 1 second.
Sure thing. Don't hesitate to ask if you have a question. Okay.
So dumb question, but on the computers, we're just setting it via the interface via fast Ethernet, correct? Under config,
Yes.
and then we're basically just making sure to set the static default gateway with IPv4 or IPv6.
IPv4.
IPv. Okay, got it.
Yes.
Let's see. Okay, just give me 1 more minute.
Yeah, right. Okay. I forgot one command. Let me add that real quick. So this is exactly the kind of time where that I usually use to answer questions in chat, by the way. So if any of you guys have any questions about what we're doing or maybe something unrelated, just again, go right ahead. Now's the time. You know, students are working, kind of don't really have a whole lot to do. Okay, guys, how are we doing?
Almost done. I'm just
Yeah, almost done. I just need gigabit Ethernet 01 on the second machine. Oh no.
You mean on the second router?
Oh my god, I think I messed up. Ah,
Okay, it's
I
fine.
messed up so
So
bad.
for the interest of time, I'm just gonna
Mhm.
go ahead with the config right now, and you can just rewatch the VOD and try to do it yourself. Again,
okay.
just like for so many things, it's not actually that complicated. It's just
Yeah, I just need to practice.
right. It's just a process, and you know, the more familiar
I
with
have
the
everything with
process.
its IPv4 address, but nothing's like green lighting to each other. That's the issue I'm running
Have
into.
you turned on the interfaces? Port status, you need to check the little checkbox that says on.
Oh, doy. Okay, 1 second.
Toy. Yeah, everything is green now.
Yeah, that one is especially deceiving. The explanation for that is so
The routers are talking to each other, but they're not talking to the PC, so I'm half done. But
okay, yeah, so you need to do that for like both interfaces, right? Turn both of them on and configure the IP addresses for
okay,
both interfaces of each router. So that's in total you have 1, 2, 3, 4, 5, 6 IP addresses to configure.
okay. I only configured 4. That was my issue. Got it.
Right, yeah. Regarding the fact that the routers don't like instantly sort of communicate with each other, the reasoning is that Cisco routers are not plug and play. Plug and play would mean you plug it and it works. The reason why is because a Cisco router does need some initial configuration, even if it's fairly minimal. Like when you turn on a Cisco router for the first time, you usually get a what's it called? A wizard that's going to basically ask you a bunch of questions like, hey, what should be the IP address of this interface and that interface, and like what are you trying to use, and what should be using DHCP, and do you want to turn on like dynamic routing and stuff like that. Um, so the routers are not plug and play because they do need some form of minimal configuration. Switches, on the other hand, are different. Switches are plug and play in the sense that if you don't do any configuration whatsoever, you can still get, so like out
All
of the
green.
box, the switches are going to work.
Same.
And not only that, they're going to adapt themselves. Like under, if you use certain Cisco technologies, they're just going to adapt themselves to the setup you have. Okay, great. So it's all green. Okay. We are going to run a couple of tests. So for instance, from the PC on the left, we're going to try to ping the router on the left. So like ping 192.168.1.1. Okay, it works. Fantastic. And then from the PC on the right, we can also try a quick ping to the router on the right as well. 192.168.2.1. The ping does work. Okay. And we're also, so we are going to start now delving into the Cisco command line. Now again, this is not something that's particularly important, but it's necessary just to do minimal setup with Cisco devices. A note on that, next Thursday, so for the next class, what I have planned is a class on using virtualization software. The reason why I want to do this is because so that we are no longer constrained with Cisco devices specifically. Because something like pfSense is easier to configure because there's a graphical interface, I would like us to use pfSense to do our labs. So like instead of configuring a Cisco router, we'd be configuring like something with a graphical interface. The problem is I can't just run pfSense in a very neat software like I can in Packet Tracer. So I would have to virtualize it. I would have to get you guys to virtualize a bunch of virtual machines running, connect them to each other correctly, and then install the proper software. And then we can finally start doing all of that. So all of that is a lot of work and needs its own dedicated, and that is just to set up our labs, just to, set up our exercises. That itself needs its own lesson. And so I'm going to try to keep it at a minimal, but similarly, it's going to be very important, and it's good. It's not just going to be useful for our labs. Like the labs are going to be the immediate benefit, but in the long term, virtualization technology is used basically absolutely everywhere. And my personal opinion is that virtualization is going to become basically the norm. Like, yeah. I do believe that eventually every single desktop is going to be running virtualization software by default to some degree. So yeah, we're gonna do that, and hopefully we'll have another mess to deal with. Instead of having to remember Cisco command lines, we're gonna have to remember, oh, how do I set up my virtual machines and stuff. But that's a lot more productive in my opinion. Okay.
Sounds great.
So, Cisco command line. We're gonna go on the router on the left, and it's possible that you were in like some menus or whatever. So just keep typing exit and exit, exit, exit until I don't think I can zoom, unfortunately. Let me see. No, I don't think I can zoom, unfortunately. So basically you have to keep typing exit until you have router with the word router with a little like little arrow, not the sharp sign, not the hash sign, but a little arrow, right? And if you don't, you have to type exit again. So let's see. This would be a good example. So you go under the CLI tab, and then here I'm on a menu, so I tap exit, exit, exit. Okay, now it should be good. All right.
Okay.
Is it good for you, Daniel, as well?
There, got it. Mine look the same as yours do now, although mine doesn't say router at the bottom.
Oh, you can just press enter.
Oh.
Daniel, do you want to show me your screen real quick?
Yeah, I think that it would be, you would see
Yeah.
even less. But wait, yeah, that's it. The router. Oh my god, I can't see anything. Okay. So exit. How do I exit? Command F6. Oh no.
Okay. Okay. So now, don't worry about it. What do you see on your screen right now? Okay.
Router.
Did you click on the router and go under the CLI
Yeah.
tab?
Yeah, I'm here. You can see it, right?
Let me see. It's taking an awfully long time to load. I think it'd be
Okay.
faster if you would just describe what you see.
I think I no.
Did you type exit a bunch of times?
Yeah.
Okay.
Kind of.
Do you have this
Oh,
this
yeah.
menu? Yeah.
Let me check. Please turn to get started. Yes.
Okay. Great. 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 So now we are in the Cisco CLI.
Okay.
So there are 4 commands that we're going to be using. So let me show them on screen real quick. So the first command is going to be the command called the command enable.
Enable.
Then it's going to be show IP route, which will display the routing table. And then if we want to add a route, we need to enter the configuration mode. So we would type configure terminal. And then there is the IP route command to actually add a route. And so that one I'll give you an example. So let's start with enable. So I type enable. And you see the little arrow next to router actually turned into a sharp sign.
Yep.
So that means we are now in privileged mode. So now I can do show IP table. No, was it? Show IP
As a
route.
musician,
Show
I
IP
appreciate you calling
route.
it the sharp sign.
I mean, there's also C#. It's also a programmer.
That's fair. That's
right?
fair as well.
It's also a programmer language. So show IP route, and here we actually can see. I'm not sure if it's very visible on Discord. So basically, the first few lines are just like descriptions. We don't really care about those. Like they're not specific to our case. It's more like, oh, remember that. Like this symbol means that, and we don't really care. What we do care about is the actual routing table is the second half of the display. And so we can see, for instance, we have, so when if one line says something is variably subnetted, it's basically not a real route. So we kind of ignore it. So we have 10.0.0/8 is directly connected. Directly connected means we are part of it. Means we automatically learned that route. And remember, that goes back to what I said last time, which is that, could you mute yourself real quick, Daniel?
Yeah, sorry.
So remember what I said last time, that the routing table will sort of fill itself automatically. And this is the result of that. Like we all automatically have, so it looks like 6 routes. In reality, it's 2. It's a little strange the way it works. This route where it says is variably subnetted, there are 2 lines like that, and those they're not real routes. And the one that starts with a little c and the one that starts with with a capital C and the one that starts with a capital L, they're basically the same. So like 10.0.0/8 and 10.0.0/1/32, those basically describe the same subnet for all intents and purposes. Again, I don't want to go into the details of what's happening here. But what matters is we do see our subnet. There are the two routes we would expect in here. 10.0.0.0/8 connected to gigabit ether to gigabit 0.1. So it's hold on, what router am I on? Oh yeah, 10.0.0/8. So on gigabit 0.1. So our link connecting our two routers. And then 192.168.10/24 on gigabit 0.0, so going to PC0. So this is basically what we would expect. Again, it looks kind of daunting, but once you know what you're looking for, it's fairly easy to read. So again, what we're looking for is basically the lines that start with a C. You can ignore the lines that start with an L. And if a line doesn't start with anything, we don't really care. We can kind of ignore it. So there are only two lines we care about. The two lines starting with a C. And those are the lines that were sort of auto-filled.
Okay.
Now, what we would like at this point, and can you guys tell me what we would like to add to this routing table? So again, this is the routing table for router 0, the router on the left. What would we like? What entry would we like to add? What subnet would we like this router to be aware of?
The other router, the 10.0.2.
Careful. It's already aware of 10.0. It's already aware of the 10.00 network.
Would this be the other computer, the 192.168.2.100?
So
A computer that's on a different network?
Think in terms of subnets instead of thinking in terms of individual IP addresses. So you're right in you have the correct direction, but the wrong aim. We're not trying to teach the router how to reach the one PC. We're trying to teach the router how to reach the entire subnet. Yes.
The 192.168.2.0 out of 24.
Exactly.
Got it. Okay.
So what we want to add, again, going back to our example here, we want to add a route that would say destination 192.168.20/24, and next hop would be the other router, the router on the right. And the interface would sort of fill itself out kind of automatically.
Okay.
So the question now becomes, how do we do that? So we said enable and then show IP route. Okay, the next one, what was the next, did you write down the next command?
Okay.
Did you write down
the command? It would be configure IP?
Nope. It's configure. You were writing configure terminal.
Configure terminal. Okay.
Right. You can also use you can also press tab to autocomplete the commands. See how I didn't have to type out the entirety of configure terminal, I just pressed tab.
There we go.
So configure terminal.
And configuration commands, one per line, and with Control-Z?
Yes. You can end with Control-Z, or you can type exit a bunch of times as well.
Okay.
Those effectively do the same thing. So now we can actually enter the command that will add our route. So I said that starts with IP route.
That's really weird. I always think of Control-Z as undoing what I just did.
Yeah, see, okay, so the Cisco CLI runs a specific operating system unfortunately called iOS, which has nothing to yeah. So
they could have picked anything.
So there was a lawsuit between Apple and Cisco, and then they eventually concluded, we're not at all doing the same thing. We're not competitors. Let's just drop this. This is a waste of time.
Okay. That's awful though.
So it was settled, but yeah, it's confusing, and it's called the iOS, and it's a real mess. That being said, there's been, like, in recent years, so I'm not gonna go too nerdy, but basically there's been huge revisions of the iOS software where now it actually runs on x86 as well. It can run virtualization software. It can be patched, like you don't have to, like, it can be properly patched without having to basically download the entire image. Like it's been really upgraded from the entire mess that it used to be. It has a Linux core now, which it didn't. It's a lot cooler now, but the commands are still a complete mess. Anyways,
Yeah.
IP route, and then what do we have? Well, again, a little bit of iOS command line. If you press question mark, you will have a display that tells you what the command expects next. So here, for instance, I can see that next, iOS is expecting me to enter a destination prefix under the form a.b.c.d. So essentially, it's asking for an IP address, just an IP address, not a mask. It's asking for an IP address that would be our destination. What is that IP address? What is what is the destination, the prefix of the destination that we're trying to add in the routing table?
Okay.
Remember, like, remember what we're trying to do right now. What destination are we trying to add to the routing table?
We're trying to add the other subnet.
Yeah.
Right? And what is the prefix?
192.
168, or
Yes.
That's it. Yeah.
Which one? 192,
Line
168? 192,
Dot-
168, yes.
Dot 2.
Dot what?
2.
After 2. I need
Ah,
4 I need
zero,
4
zero.
bytes.
Yeah,
0.
yeah.
Yes. Correct. So in practice it actually wouldn't make a difference if I type .0 or .100, or as long as I use a /24 mask afterwards. But for the sake of clarity, let's be very accurate. What I'm trying to add is the subnet 192.168.2.0. Okay, and then I press space, and I can press question mark again, and now it's asking for the destination prefix mask. Now the mask is a /24, but it's asking for like the full notation. So what would be a /24 here? What would be the equivalent? If I had to type,
wouldn't it be 255, 255, 00?
almost, it's 250, 255, 255, 255, 0. /24 means the 24 first bits, which means the 3 first bytes are all ones. And 1 byte being all ones means its value is 255. The first 3 bytes are 255. I think you could benefit a lot from like working on your binary a little bit.
Yeah. I can start practicing that.
Right. Because hexadecimal is something else, but like it's very, very important to be fluent in binary when working with networking, or at the very least not be afraid to get into it, because like it's gonna appear basically all the time, even if it's like kind of hidden like we just did. It's like it has to be like it would be best if it became a second instinct, basically.
No, I get it.
Okay. Then again, question mark, let's see what it asks for. Ooh, it asks for a bunch of stuff. But basically what it asks for right now is going to be the next hop. So the next hop can either be an IP address. So we could forward it, for instance, to IP to the other router, or it could be like an interface. But for the sake of simplicity, I'm just going to use an IP address here. So I'm going to say, so okay, what we're trying to do is add a route to subnet 192.168.2.0. Where do I need to, from router 0 here, where do I have to go to reach this subnet? What IP address do I have to reach? What device am I trying to go through first?
So we would need the router IP address of the subnet, or no?
Okay. Fundamentally, what we're doing here is kind of similar to configuring a gateway. Right? Remember when we configured our gateway for the PC? Our
Okay.
problem was, okay, who do I pass the ball to? Who do I forward the packet to? Right? What is the IP address that I need to forward the packet to? Here it's pretty much the same thing. Is under those conditions, and those conditions being that the packet would have to go in this subnet, under this specific condition, what IP address do I have to forward the packet to? So if someone tries to reach subnet, so if I am router 0 and I get word that, and I get a packet that someone's trying to send to the subnet 192.168.2.0, who should I forward that packet to? Let's just think in terms of devices first.
The router
Which one?
1.
Router 1.
Router 1, yes, on the right. Okay. Now, does router 0 know about the 192.168.2.1 IP address?
No.
No. Does router 0 know about the 10.0.0.2 IP address?
Yes.
Yes.
Right.
Oh my God.
Okay. So I'm giving it what it doesn't know then.
Exactly. I need to forward it to something it already knows. So I need to forward it to 10.0.0.2. Does that make sense?
Okay.
Okay. So the full command would be IP route followed by 192.168.2.0. So the destination prefix, followed by 255, 255, 255.0. So that would be the destination prefix mask, the mask. And finally, the IP address of the next hop, which would be the IP address of router 1 that router 0 is aware of.
Okay.
And
Wow.
if you type question mark again, you can see you can either type something called a metric, or there's the CR. CR means you can just enter, you can press enter and finish the command right now. So let's do that because we don't care about metric here.
Yeah, I see distant metric. I'm like, oh no.
Yeah, metric is interesting, but again, like not strictly necessary. So, okay, and then what? There's no confirmation, no nothing. Well, let's go ahead and check back in our routing table. So let's go exit to exit configuration mode and type show IP route. And oh, would you look at that? Here's a new line. So this new line starts with an S, and if you look up there, if you look for S, you will see that a capital S means it's a static route, which is what it is. It's a static route. We just added a static route to the routing table, and now it actually shows up. And what we see is 192.168.2.0/24. You can ignore this, the 1/0 in the middle, via 10.0.0.2, which is the IP address of router 1. The IP address of router 1 that is facing router 0.
Okay.
So basically, we've just added the route. Does this make sense? Is this...
That does make sense. Correct.
Yeah, okay. So now, if PC1 on the right was to attempt... Okay, so hold on. Let me pull up Epic Pen right now, because we have something kind of interesting right now going on. Because basically we have a situation where we have an asymmetric setup. So basically, let me ask you guys, do you think, so right now, normally, this router can reach this subnet. It should work.
Okay.
However, this router cannot reach this subnet. Does that make sense?
Yes.
Okay.
Yeah, it makes so much sense.
So can this PC ping this PC? So let's run through it. So let's see. This PC is trying to ping 192.168.100. We're trying to ping 192.168.100. So the PC0 will conclude, okay, I need to leave my subnet. Therefore, I have to ask my router. I have to ask my gateway. So the ping will be passed onto router 0. Router 0 then looks in its routing table and it sees, oh, 192.168.100, that belongs to the 192.168.20/24 network. And I just had a route added for that specific network. And I know that for that route, I need to pass the packet to router 1. So far, so good?
Yes.
Yeah.
Then router 1 looks in its own routing table and sees, oh, wait, I'm actually in the destination subnet. So I can just pass it on directly to PC1. So let me ask again, would the ping work? Going from PC0 to PC1?
Yeah, but all the packages would be lost.
What do you mean?
That they could go, but they wouldn't be able to come back.
Exactly. So the answer is actually no. Because for a ping to be validated, the round trip has to be validated. So you are correct that the round trip does not work. Because what happens when I try to go to essentially send a receipt to PC0? PC1 tries to send a receipt to PC0. What happens? Again, same deal. Basically, PC1 looks at the IP address 192.168.1.100, concludes that it needs to pass the packet to its gateway, and then router 1 looks at this IP address and says, I have no idea where the fuck that is, and just drops it. And that's it. End of the story.
It's not that bad.
Well, we're halfway done, but
Okay.
just by configuring but what I'm trying to get to here is getting you used to running those steps so that you can then you do it yourself and sort of use that to troubleshoot if you have misconfigured something to see, okay, like you can, for instance, try, okay, can I ping to here? Okay, can I ping to here? Okay, can I ping to here? This ping fails. Okay, let's try pinging between these two to see if it's an IP issue. Let's try pinging between these two to see if it's an IP issue. No, the pings 1-to-1 work, so it's a routing issue. You know, that sort of troubleshooting process. To understand the troubleshooting process, you have to understand the routing process. Okay. However, I will say this, that despite the fact that right now we have asymmetrical routing, there is still a ping that we can do right now that we weren't able to do previously. Do you guys have an idea of a ping that we can do now? So again, all that we did was adding a route to this router on how to reach this subnet. What's a ping that we can do now that necessitates this route and only this route? I mean, on top of like what we had previously. What was a ping that without this route we cannot do, but with this route we can now do?
Well, we can now interact with, so we can send stuff from the first PC to things on the second subnet, correct? And vice versa? Or only one direction at the moment, because we don't have it for the return trip.
I'm not sure I understand what you're saying.
So you're asking what we can do now that we couldn't do before, and I was
Mm-hmm.
going to say send stuff from PC0 to PC1.
Well, yes, but okay. When I say the ping, when I say that we have that the ping works or something like that, what I mean is that we have round trip connectivity. I specifically mean round trip connectivity, not just one way. I mean two-way connectivity.
Maybe it could be to the router.
Okay, I
PC0
like what you're
to
thinking.
router 1.
Okay, let's try that. Okay, let's actually try and run through that. So I am PC0. I'm trying to ping router 1. Which IP address? Because it has two IP addresses.
192.168.2.1.
So for technical reasons, I'm going to tell you that that's not a good idea. Is this the new league update? If it were, man, I'd be challenger. So for technical reasons, it's usually a better idea to ping the interface that's going to face us. You know, like we're sort of moving in this direction, and the IP address 10.0.0.2 is the one facing us. So it's a safer bet to try and ping that one. Pinging 192.168.2.1, even if you had connectivity, it's not 100% certain that you'd be able to reach it. It's kind of complex. It basically comes down to how the router works internally. It's not a given that you can just reach it. So I wouldn't. So it's kind of a risky move. But if what I want to test is the connectivity between PC0 and router 1, the safer bet would be trying to ping the address 10.0.0.2, the address that's facing us.
Okay.
Okay.
I didn't know that.
I know that. That's fine. That's fine. So I'm trying to ping 10.0.0.2. So what happens? PC0, you know the drill now. 10.0.0.2 is out of my subnet, so I contact my gateway. Router 0, does router 0 know IP address 10.0.0.2? Does yes, right, because it's a neighbor. So I can directly contact my neighbor. Great. The ping is now valid. What about the way back though? Router 1 is now trying to reach 192.168.1.100. Is router 1 aware of the network 192.168.1.0? Is it in its routing table? Have we configured a route for it?
No.
Okay, we haven't. Does it know about this network like automatically? Is router 1 aware of 192.168.1.0 automatically? What would it take for it to know? What does it take for a router to know about a network automatically?
It either be a neighbor or it.
That's pretty much it. It has to be a neighbor, right?
Okay.
The router would have to be in the network itself. So is router 1 in the network 192.168.1.0?
No.
No. So is router 1 automatically aware of 192.168.1.0?
No.
Have we added a route to 192.168.1.0 on router 1?
No.
So can router 1 reach subnet 192.168.1.0?
No.
Exactly. So the round trip does not work. But here's the crucial thing. And this is where I actually liked your idea here. See, let's look at router 0 here. For this whole thing, like basically, router 0 is our perfect middleman here. We're trying to connect PC0 and router 1. Router 1 automatically knows both of them, right? Because he's in both networks. Right?
Right.
So fundamentally, we wouldn't even need to configure router 0. with any routes at all, right?
Yeah.
But we would need to configure router 1 with a route. Do you agree? We would need to tell router 1 about this network. So we would have to give a route to router 1.
Okay, so we're basically like trying to tell the two subnets about each other so they know where to route everything.
Hold on. I want to make sure Daniel follows me on this one.
Okay.
Daniel, do you like the scenario that you've given me where PC0 tries to contact router 1? What I'm trying to show you is that basically you had the right idea, but in reverse. We've configured a route on router 0, but in this situation, router 0 does not need a route. We have not configured a route on router 1, but in this situation, router 1 needs a route.
Okay.
So now I ask you again, what's a ping that didn't work previously that will now work? And you had the right idea, just in the wrong place. Just take exactly what you told me and just mirror it.
Oh my god! I think that maybe
Okay. Let's walk.
maybe
Well, let's just take this
one.
logically again. Router 0 has a route but didn't need one. And router 1 needed a route but didn't have one. Right? So router 0 has it but doesn't need it. Router 1 doesn't have it and needs it to ping like this.
Okay.
So what happens if you just mirror this? Essentially, I'm
Then-
talking about this ping.
Yeah.
What happens then?
Okay. So.
Okay, so yeah, walk us through
Okay.
through the process, and I'll just draw as you explain what happens.
So if PC1 wants to ping router 0,
Yes,
it would ping to 10.0.0.1,
correct.
and the ping would go to router 1 and then to
Yes,
router 0,
yes. And then what would
and then
happen?
from router 0 it would check its router
Routing table.
routing table. Yeah, sorry.
Yes. And
And
is
then it would
router
check.
0 aware of this subnet?
Yes.
Yes,
it is.
because we added the route.
Oh my god.
So now,
Okay.
in fact, router 0 can route it back to router 1, and router 1 routes it back to PC1.
Yes.
So the answer is yes, there is one ping that we can now do that we couldn't previously. So let's see if it works. I certainly hope it does. I'm gonna look like an idiot if it doesn't. So let's see. Ping 10.0.0.1. And it looks like, oh, hold on. Maybe a couple. Okay, I do look. Wait. No, that was the one. Okay. If the first one fails, it's fine. All you need is one to work. Or one ping to work. And so you see, it does work. But just for sanity, as a sanity check, let's try from PC0 to router 1 like you suggested. Let's try pinging 10.0.0.2. First ping times out. Second times out again. This is not looking good. But this is exactly what we theorized. Oh, looks like it's bugged out, but it's basically not working. Yep. Sent 4, lost 4. So this is a classic example of what we call asymmetric routing. Where basically there might be a route to a place without without necessarily being a route back. Or like if there's a route back, it might be that it's not the same route. So that would be asymmetric routing. And by the way, usually we try to avoid asymmetric routing.
Okay.
So I know that was a lot to take in, but we're almost done.
It's something where we just need to route a few tables and then try to add a third router in there just to kind of get the routing between multiple things.
I'm not sure I understand your question.
I'm just saying basically like try to replicate it a few times and then just see how one goes to the other, try it with different IP addresses and just kind of practice. Like when
Right,
you do
exactly.
a problem with different.
The bottom line, I mean, if you want to take it easy, the bottom line is just look at the router, see what subnets it's a part of, and add a route for any other subnet that it's not a part of. And really, that's it. If you follow that and you know how to add a route, and you do that for every router, so like you do it for router 0, and then you do the exact same process for router 1, you look at it, okay, it knows this subnet, it knows this one, it doesn't know this one, so I need to add a route, you know. If you do it very systematically like that, you're going to be fine. That's the bottom line. Where it gets really interesting is when we start really understanding how the IP packet itself will behave if we, for instance, like forget to configure a route. What happens then? Well, it leads to that scenario of asymmetric routing where there's a way to the destination but no way back. Okay. So now let's just finish this and just go over to router 1 and add a route to 192.168.10/24. And once that's done, we should actually have full connectivity. So again, I'm going to type enable show IP route, and I see the routing table. Let's see. I know, so router 1 knows networks 10.0.0.0/8, 192.168.2.0/24. So that makes sense. That's what we would expect. And then configure terminal. And then I'm going to add our static route, so IP route. And at this point, you should know the drill. So I'm just going to like do this one a little bit quickly. IP route 192.168.1.0.255, and then 255.255.255.0, and then 10.0.0.1. Okay. And if I go now, if I do exit to exit configuration mode, so that I can now do show IP route again, I can see that my static route was in fact to the network 192.168.10/24 was indeed added. And if I now go over on to PC1 and try to ping router 0, for instance, actually no, the other one, right? PC0 pinging router 1. So the ping that did not work previously, it now works. And so that means that in theory, PC1 and PC0 should normally be able to ping each other. So let's try. Ping 192.168.2.100. And it works. We have full IP connectivity between PC0 and PC1. And theoretically, between any IP device in the subnet on the far left and any IP device to the subnet on the far right. Are we clear on all that?
Yes.
Yes, okay. Quick question to make sure that it's very clear. What if I was to add a third subnet? Let's say, so I add a PC. Oh, crap. Okay. Give me a sec. I'm gonna need to shut it off. And okay, this will do. Where's the yes? Okay. Okay. Config. Yes, still booting. Okay, it's taking a little bit. And then can I fast forward? Yes. Do I have to turn them back on? I do. Oh, really? Well, whatever. Okay. So let's say theoretically, I was to ask to add a third subnet right here. How many more routes do I have to configure in total in my setup?
To get this third subnet to talk to which subnet again?
I mean so that we have
Full connectivity.
full connectivity between all the subnets.
Okay.
How many more routes do I need to add? So again, think about what we did just now with like the blue circles and purple circles.
It would need to be connected to 192.168 to 1. Because that's on a different subnet. Oh, but it is on the same router though.
Exactly, right.
So we don't need to do that because they're neighbors.
Yeah, router 1 already knows about this subnet, so we're good for this one.
So we just need to tell it about 10.0.0.2.
Tell
10.
what
Oh,
tell
no,
route
sorry.
what router exactly. Again, we need to tell routers
Sorry, I was
about
doing
subnets.
it from the PC side of things, not.
Yeah, no. The PCs don't give a shit. The PCs just
Yeah.
throw the packets to the route to their gateways, and that's it.
Got it. Okay.
Okay, so I think that we would need to configure two IP addresses. No.
I mean, assuming we have configured this PC and this interface correctly. I'm talking strictly about routes.
Okay, so only one.
Yeah.
In maybe in router 0.
Mm-hmm.
I'm sorry. In router 0, we would need to configure the IP address for the PC2.
So you have the right idea. It's for the subnet of
okay, I see what
PC2.
he's
Yeah,
I see what
subnet
he's
of
saying.
PC2. Yeah.
Because again, we need like remember the process. You take one router, you look at all the subnets it's a part of already, and any subnet that it's not a part of, you need to add a route to it. And yes, in fact, this subnet is a subnet that router 0 is not a part of. So we need to add one extra route compared to what we had previously. Let's do the same thing for router 1. Router 1 is part already of the new subnet, so we don't need to add a route. Does it make sense?
Yes.
Okay. Is it clear? Yeah, go ahead.
And then you could just build it out from there if you had additional computers and routers.
Exactly. So I'm going to show you an example of where it gets really tricky. Like, okay, what if I had like, I'm going to draw very crudely, but hopefully that demonstrates the purpose. Let's say I have like 1, 2, 3 routers, and then 1 subnet, 2 subnets, 3 subnets. How many routes do I have to configure here? Well, if we just do the process, no, way more than that, actually.
Well, okay. Sorry.
So again, that's the thing. It's the amount of routes we have to configure, to manually configure, grows up exponentially as we add routers.
Okay.
So for instance, let's check for this third router. So it knows this one, and we need to configure, let's see, 1, 2, and 3 subnets just for this one. Okay. Oh, crap. I didn't mean to do that. Okay.
Oh, I see.
And then for this router here, the middle one, well, it knows this one, this subnet, this subnet, this subnet, and then we need to configure this one and this one. And then the router on the far left, it knows this subnet, and we need to configure this one and this one and this one. So that's a total of 8 routes to configure.
So if it was in the middle, it needs to configure 2, and if it's on the left, it needs 3. If it's on the right, it needs 3. Just in this case.
Exactly. What happens then if I add just one more router like here, and I connect it like that, and I add a subnet here? The answer, it becomes a fucking mess.
Okay.
Right. So
Okay.
this is why static routing, there are only really 2 cases where we use static routing. Either you have a very small network, or in specific cases for routing on the internet, or like very specific, very niche enterprise cases. But fundamentally, as far as you're concerned, if you start, essentially if you have more than 2 routers, so that would include firewalls as well, right? Like, let's say you have 2 firewalls and a router, that is when you might start thinking about implementing dynamic routing. Because what happens if suddenly this network is unavailable? Well, a dynamic routing protocol could like rearrange everything automatically, but static routing will be stuck and just lose packets, right? Because it will keep trying to send packets maybe to a dead end. So
Okay.
there is a point where static routing is not sufficient to route your entire network if you have like more than, let's say, 2 routers. So I think that pretty much covers it. How are you guys feeling?
So I'm gonna definitely need to practice this, and I'm gonna try to do it a bit tonight. But
Mm-hmm.
I do at least get the concept of it.
Right. So this idea of routing, like your router does this. However, what your router has is a special route called the default route.
Okay.
That is a concept that's a little bit complicated to unwrap fully. But the bottom line is that a default route is quite literally the same thing as a default gateway. In fact, it's so much the same thing that when you configure the default gateway on a PC, you're actually altering the PC's routing table. Because in fact, your Windows PC has a routing table. Your PC is in fact a router. There is a service in the Windows options, in the Windows services. There is a routing service that is disabled by default, but you can enable it and turn your Windows PC into a router. And the only thing you need to be a router is have several interfaces. Now you might tell me, but I don't have several interfaces, I just have the one. Well, your Wi-Fi interface also acts as an interface. So if you have a laptop with an Ethernet port and a Wi-Fi card, that laptop can serve as essentially as a router between Wi-Fi and wired.
That actually makes a lot of sense.
Mm-hmm. And if you add extra like Ethernet cards, like add-on cards to your PC, that also could turn your Windows PC into a router. So the command to let me see if I remember this right. I think the command to see the routing table on Windows would be display route. No. Crap. Okay, let me Google this real quick. Windows show routing. Okay, show route table. In the command line. route print. Let's see, route print. Yes. So if you type route print right now in your Windows command line, you will see the routing table of your Windows PC. And you'll see there's, what's that?
In the command function, right?
Yes, in the command line, yes.
Okay.
Let me think. I don't think I'm doxing myself if I show this. So I can, for instance, show you this.
Oh, I see.
So, yeah, you see that there's actually a bunch of routes, but the one that's the most important is actually the one that's on top here, and that says 0000 and 0000. That is our default route. That is our gateway, and it makes sense. It says gateway here, 192.168.1.1. You can think of the term gateway. Gateway means the same thing as like next hop for a route. Remember when we were configuring our routing tables and we were saying, okay, here's the destination, here's the mask, and here's the next hop. Next hop is the same thing as the gateway. Your gateway is quite literally just a route, but it's the default route. It's if all else fails, if I have no other clue where to send this, send it to the gateway. Does that make sense?
Okay.
And your home router basically has also a default route. If you're trying to access the internet, that's going to match against the default route of your router. And when something matches against the default route, it just sends it to your ISP, which then handles the rest. But if you were to configure your router with extra routes, like let's say you have an extra internal subnet or whatever, instead of sending those packets to like your ISP, your router could actually still reroute it internally. So there's actually quite a lot that you can do even with like minimal equipment. Again, though, you have to know what you're looking for. You have to know what you're doing. And you have to understand subnetting and routing, which is why this is so important. Even though in practice, like from my experience, I've never really had to bother personally with for personal projects. I've never really had to bother with routing. Well, that's not exactly true. There's the one case where I had to bother with routing is basically telling my PC to like for very specific routes to like use a different gateway than the default one. So at that point, I had to add routes to my PC, which, by the way, was actually kind of annoying. Windows does not make this very easy. But anyways, yeah. So again, like that little bit of a rant here at the end, it's to try and give you some context. There is this default route that's basically a gateway, and your router, your home router, has one that points to your ISP.
Okay.
Okay. How are you guys feeling?
Well, it's definitely practice time, but outside of that, I got it this time.
Okay. And so one last thing before I go, because I promised that, let's do a quick, simple Wireshark demo.
I might have to look on yours. Mine is stuck at 40%.
Yeah, sure. So I mean that I'm running one right now. So I have applied an ICMP filter here at the top, which means it's only going to be looking at pings. So I'm going to start. And then from the command line, I'm going to ping the internet. So 8888, for instance. And here you see, for every time a ping is sent, I'm seeing some new lines on my Wireshark. So then if I stop the capture, and look at. So I see here there's a pattern. You know, it's request, reply, request, reply, request, reply, request, reply. Because every time it's Wireshark is going to capture the packets that are outgoing and the packets that are entering.
Oh, okay.
And so if I, for instance, look at this very first request, so the ping I sent, first of all, Wireshark sort of gives me a good, like just the menu, like the sort of menu here at the top gives me a decent summary. So for instance, time is like how many seconds since I started the capture. So it's just a history. Source. So that is the source IP address. Again, remember, we talked about the IP packet last time. This is the source IP address. Destination is the destination IP address. Protocol is like a general protocol of what is being used for that packet. So here it's ICMP, and then there's a bunch of other stuff that we haven't necessarily mentioned. And then if I go to the menu below it, I see frame something. I don't know what that is. Ethernet, I don't know what that is. Internet Protocol version 6. Okay, let's drop that down and have a look. And I see, for instance, a few things. Okay, I don't know what that is. Oh, source address, destination address. Right here, it says source and destination. So this is how you can like quite literally use Wireshark to just monitor your own network traffic. So
That's really cool.
yeah. So what you could do, for instance, is like just for like exploration's sake, you can just run Wireshark right now, not just for ICMP, just run it for like a second, stop the capture, and then pick one packet at random and look at it, like look at the IP addresses, and then try to do some research on what that IP address is.
Oh, so is that how people dox other people?
That would
To
be
a
one way.
degree.
Yes, that would be
Yeah.
one way. Like, for instance, there used to be a feature on Steam, and it might still be the case that where when you called people through Steam, you were calling them on their IP address, and therefore, like just the fact
Oh
that you're
no.
calling them, you
Oh
can
no.
retrieve their IP address. And if you have someone's IP address, what can you
Who
do?
thought that was a good idea?
Steam apparently.
Oh god.
Bless Gaben.
Damn it, Gavin.
And the thing is, when you know someone's IP address, what can you do? Well, you can just spam their IP address of just pings, like a million times a second. And that's effectively a DOS, not a DDoS, a regular DOS. DDoS would mean there are several people attacking at the same time.
Yeah,
Oh
But
my
you're alone.
god.
Because DDoS is dedicated denial of service.
Not
correct?
dedicated, it's
Or no,
distributed.
distribute. Oh, that's right.
Right.
Freaking
Distributed
Lizard
meaning
Squad back in
several
like
people.
6-7 years ago.
Okay. Wow.
Right. Discord, for instance, as far as I know, is not peer-to-peer. So even if you guys were to like monitor your network and your network card and like try to see where the packets are going and coming from, you would not see my IP address because it's
Okay.
not peer-to-peer. You would find the Discord IP address, the Discord server IP address.
Wait. So if I use torrent to
Yes,
download a
yes,
file,
yes, yes.
do you know my
But you
IP?
don't even. The thing is, for torrenting specifically, you don't even need Wireshark. You can already see the IP addresses of the people you're connecting to in the client.
And they can see mine.
Yes,
Oh
you
my
are
god, I
broadcasting
didn't
your
know
IP
that.
address on when you're torrenting. Yes, that is why you need to use a VPN for that sort of shit. It's not just so that the government can't track you. It's also so that other torrent you're not broadcasting your IP address to a bunch of strangers.
Oh god.
Good thing you never torrent. Yeah, I mean it's fine as long as you torrent, private pictures of family vacation, which is obviously what
Torrent
people
responsibly.
use torrenting for.
I mean, I only did it once for a Linux variation.
Yep.
So that university has my IP address somewhere in their
Well,
archives.
also keep in mind that if you were to download it directly through HTTP, so at that time, if you download a file through HTTP, so like off of a website, that is, so HTTP is not peer-to-peer, it's centralized. The website you are downloading the file from, they have your IP address. In fact, whenever you browse the web, any website that you visit has your IP address.
Oh.
I mean, yeah.
Yeah. That's
So
how the internet works.
Amazon have your IP. Google has your IP. Facebook has your IP. Any website you've ever been on has your IP. And if you've entered personal information, they can match your IP address to your personal data, create a database, and sell that to advertisers to say, if you ever find that IP address, it's Daniel's. And he's an Amazon customer, and he's just purchased programmer socks recently. And they build a profile.
Sorry.
Oh.
God damn it, I'm about to. I feel called out.
So that is this is in fact why, and I would be down to like do a. I already have a like a very, I think, a pretty well edited series on my on YouTube already dedicated to like I did one big lesson on VPN and like how it actually protects you and how it doesn't. So you can check that out if you guys are interested, and tell me in the comments as well and on Discord if you guys are interested for me to do another sort of class on VPN, commercial VPN, and how it can protect and how it cannot protect your private data. And you know, it's not exactly the same thing if we're talking like protecting yourself against governments versus protecting yourself against companies. Like those aren't actually the same thing. We can definitely do that again. I'd be down. So you let me know in the comments on Discord, all that. All right. Well, guys, I think that was it for tonight.
Yeah.
Anything to say about today's lesson?
Well, definitely something I need to practice, and also, again, I apologize for being late.
No worries. I have a question relating to like how did you feel the, I want to say sort of the transition was between last time and this time? Like, was it clear? Should we
A little bit more smooth than from week 1 to week 2.
Yeah. Better.
Okay. Noted. Well, I think that is it then. I'm gonna mute myself for a second. So there we go, guys. That went pretty well. Again, if you have questions or comments or like remarks or anything, don't hesitate to hit me up in the comments, and do hop over to Discord. We have more and more people joining every day. That's not true. And I'd be really interested to hear some of you guys' thoughts. And if you have any specific topic, like literally anything, if there is one topic that you'd like us to cover on this channel, please go ahead. If I can't cover it myself, I will certainly find someone who will be down to make a class on that. So on that note, thank you very much for watching, and I'll see you next time.